Hello, today we're going to talk about points in space. So we're going to do a quick review of the distance and midpoint in a two-dimensional plane. So if A is located at x1, y1, and B is located at x2, y2, the points in the plane will end up creating the distance formula of just taking the square root of subtracting your x values and then squaring them, and then adding them to subtracting your y values and then squaring them. Midpoint. If A is located at x1, y1, and B is located at x2, y2, then the midpoint is going to be the mean of the x value or the mean of the y value written as a point. So let's look at number 1. Find the distance between A and B. So remember, we're using the distance formula. So I know that my distance is going to be equal to x2, which is 3, subtract x1, which is -2, squared, plus 4, which is y2, minus 1, which is y1. Then I simplify everything, so I know my distance is equal to 3 subtract -2 is the same thing as 3 plus 2, and that's 5. So that'd be 5 squared plus 4 minus 1 is 3, so that's 3 squared. And we end up getting 25 plus 9 under the radical. And 25 plus 9 is 34. So finally, the square root of 34 is approximately 5.83 in 3 significant figures. All right. So let's look at part B. Part B states that we are trying to find the midpoint of AB. Okay, we're trying to find the midpoint. So we're going to use the midpoint formula. So the midpoint is equivalent to you adding your x values together. So -1 plus 4 divided by 2. And then adding your y values together and dividing by 2. So that's going to be 3 plus 7 divided by 2. So we already know that -1 plus 4 is 3. And then we have 3 divided by 2. And then we have 3 plus 7, which is 10. And 10 divided by 2. So your final answer will be 3 over 2 and 5. That will be the location of the midpoint. If you want to write 3 over 2 as 1.5, that is fine. Part C, it says, M is the midpoint of RS. Find R, given that S is located at -1, -3, and M is located at 2, -2.5. So in order to find an end point, when you're given another end point in the midpoint, you have to understand the formula for the midpoint. So we know that if we have our midpoint, which means the x value of the midpoint and the y value of the midpoint, that is equal to taking your x values and adding them together, dividing them by 2, and then doing the same thing with your y values. So if you think about this, you can create 2 equations, okay? You can create 2 equations. And sorry, I'm just reorganizing this so it'll fit. All right, in the two equations that you're going to have, is that the x value of your midpoint is equal to the sum of the x values of your endpoint divided by 2, and then the y value of your midpoint is equal to the sum of your y values divided by 2. So if I look at the x values of my midpoint and the endpoint s, I know that in order to get the x value of 2 for the midpoint, I had to say -1 plus some value divided by 2 is equal to 2. So with that, I know I multiply both sides by 2, so I have -1 plus x is equal to 4, and then I add 1 to both sides, which means x has to be equal to 5. I'm going to do the same thing for the y values. So I know that the y value of my midpoint is formed by saying that y value of the endpoint of s, so that's going to be -3, plus some y value divided by 2 is equal to -2.5. So I'm going to multiply both sides by 2, so I end up getting -3 plus y is equal to -5, and then I'm going to add 3 to both sides, which means y is going to be equal to -2. So I see that the point R is located at 5, -2. And I know that I'm right because if I look at R and S and I find the midpoint the normal way by adding the adding the x values and dividing by 2, adding the y values dividing by 2, I will end up getting the midpoint that was stated. All right. So now let's talk about plotting points in a 3-dimensional plane. So we're used to having a 2-dimensional plane, just an x and a y axis. However, in coordinate geometry, we identify points and plot them as x, y, z. Okay, in a 3D plane. The the y and the z axis on the 3D plane are just like the x and y axis on the 2D plane. The x-axis of the 3D plane is going to look like it's coming out of the page. All right. So if we look here, normally when we make a coordinate plane, we normally draw x and a y-axis. In this case, it's going to be a y and a z-axis. So this is the y-axis here. This is the z-axis here. The x-axis looks like it's coming out of the paper. So example 2 states that we want to plot the point 3, 4, -2 on the coordinate plane to the right. So remember, we are drawing a 3-dimensional, we're drawing in a 3-dimensional plane. So we should be thinking in 3D. So if I want to plot the 3, okay, that means I need to go to 3 on the x-axis. So I'm going to come out of the origin and I'm going to go to where that 3 is. Then if I want to figure out, okay, where's the 4 on the y-axis, I go to the y-axis and I go over to 4. So what's going to happen is it's best to look at the parallel lines. So I know that 3, 4, if I go to where that 3 was and I draw a parallel line to the y-axis, just extending out, this is what I will end up getting. And then if I look at a parallel line to the x-axis and sketch it, this is what I will end up getting. So as you can see, I'm drawing like the base of the geometric figure. The next thing you want to do is you want to identify the z-coordinate, which is -2. So on the z-axis, I'm going to draw a line going down to -2. Now what I'm going to do is I'm going to start drawing my lines that are parallel to the z-axis, and I'm going to draw another dotted line that's parallel to the x-axis to create a face of my 3D figure, so to speak. Once I do that, I can draw a parallel line to the y-axis, and then I'm going to draw another line that's parallel to the x-axis coming down like I'm making a face in the front, and then I'm going to come down in the back and then make another dotted line parallel to the z-axis again. So the location of my point is actually here. So this is the point, 3, 4, -2. So all you're doing is you're basically drawing a whole bunch of lines, identifying where on the X, Z, and the Y axis you need to start, and then you're drawing a 3D figure. And then you can locate where your point is. So that is how you draw the point in 3 dimensions. All right. If you need help with plotting points in 3 dimensions, please let me know and I will assist you even further. So now let's look at the distance and midpoint of a 3-dimensional figure. So it says find the distance and midpoint of JK if J is located at 5, -4, 2, and K is located at -1, 3, 0. So we do the same thing like we did in a 2-dimensional plane, except for we have X, Y, and Z. So same exact thing. So let's find the distance. So the distance is equal to the difference of your X value. So we're going to do X2 minus X1 and Y2 minus Y1 and Z2 minus Z1. So I'm going to have -1 subtract 5 squared plus 3 subtract -4 squared plus 0 subtract 2 squared. So I'm going to use the calculator to do everything on the inside of the radical. So I have -1 minus 5 squared plus 3 minus -4 squared plus 0 minus 2 squared. So all of that under the radical simplifies to 89. And then if I take the square root of 89, I end up getting approximately 9.43 in 3 significant figures. So that is my distance. For midpoint, remember for midpoint, you're just adding your X values, dividing by 2, doing the same thing to the Y and the Z values. So if we do that, we're going to have 5 plus -1 divided by 2. Then we're going to have -4 plus 3 divided by 2. And then we have 2 plus 0 divided by 2. So we should already know that 5 plus -1 is 5 minus 1, which is 4. So we're going to have 4 divided by 2. -4 plus 3 is a -1. So we're going to have -1 divided by 2. And then we have 2 plus 0, which is 2 divided by 2. And then we simplify. We end up getting 2, -1/2, 1. And if you want to write -0.5, that's correct still. You write it in decimal form. So here, this is our midpoint. All right, so let's look at number 4. Number 4 says that M is the midpoint of AB. Find the other endpoint of AB if M is equal to M is located at -4, 3.5, and 7, and B is located at -6, 7, and 3. So remember, your midpoint is equal to the sum of your X values of the endpoints divided by 2, and it works the same way for the Y values as well. So I know that basically for the X value of my midpoint and the X value of the endpoint, B, I can say that -6 plus some number divided by 2 should have been equal to -4 because we have to find the X value and the Y value and Z value of the other end point. So I will multiply both sides by 2, so I get -6 plus X is equal to -8, and then I add 6 to both sides, so I end up getting that X is equal to -2. I also see where I have 3.5 for the Y and 7 for the Y. So remember, 7, which is the Y value of one endpoint, plus the Y value of the other endpoint, divided by 2, should have been equal to the Y value of the midpoint, which is 3.5. So if I multiply both sides by 2, I get 7 plus Y is equal to 7, and I subtract 7 on both sides, so I end up getting that Y is equal to 0. Last but not least, I do the Z values. So I can say the z value of the endpoint of B is going to be 3 plus the z value of my other endpoint that I don't know divided by 2 is going to be equal to the z value of my midpoint, which is 7. All right, and make sure that's a z. So if I multiply both sides by 2, I end up getting 3 plus z is equal to 14. And then I add, subtract 3 on both sides, so I get z is equal to 11. So I know that the point A is located at -2, 0, and 11 in order for the midpoint to be what it is. All right. If you have any questions, please let me know. I will be more than happy to assist you. Have a great day.